All right. Very good morning. Very good evening. Right. So let's continue with our demo sessions in continuation to the yesterday's class. Right. So let's quickly recap what we covered yesterday in few minutes, and then we'll get started with a few more topics on this rack architecture and networking. Right. So we started with the introduction about me, my overall experience, and my overall journey, and my areas of expertise and which all domain I worked and what are major projects I handled in my career, and then what are the advantages of cloud. Is the cloud is going to impact DBA jobs? What are the advantages of learning the DevOps skills? Is it mandatory for DBA to learn these DevOps skills? And couple of others questions which regularly discussed in our any friend circle or any of our previous batch students. So those are the regularly asked questions what we discussed yesterday, and followed by we discussed about course curriculum. So I can quickly open it and show it one more time here. So this is the course curriculum. I'm not gonna brief once again. So yesterday we did a deep dive into this entire course curriculum and topics. So let's anyone had not attended yesterday's session, request everyone to go ahead and then watch that yesterday session, and then any questions or queries about this course curriculum or content, feel free to ping me in my WhatsApp or email me. And then we also discussed about course timing and the course structures and the duration and fee structure. So go ahead and then take a note of this blog, Malik034 blogs.com and upcoming batch schedule. So already opened here. So it clearly says when is the class is scheduled and other thing. And this Google Drive here, which talks about the timings, the schedule, and the fee structure and all those things. So yesterday and today are the two demo sessions where we're using this Zoom link, and this is the course curriculum what I just gone through. And our actual class is going to start by next weekend. Next Saturday we'll be starting our regular classes for this RAC course. Okay, and take a note, this is a weekend batch, Saturday, Sunday only. And timings are going to be 8:30 AM IST to 12:30 PM, 4 hours on Saturday and 4 hours on Sunday. In Eastern time zone, it will be 11:30 PM EST to 3:30 AM EST, 4 hours on weekends. And within 5 to 6 weekend, we should be able to complete this course. And this is a paid training. Will be having 15,000 Indian rupees as a course fees, or 185 US dollar. And the course will be conducted via live online Zoom session, which will be covering 19C version. And everyday sessions will be recorded and uploaded into Google Drive, so you can watch the recordings if you miss the recordings of that day. Right, and also we covered about minimum requirement, because without meeting this minimum requirement, you'll not be able to understand the course, or you'll not be able to do a hands-on lab exercise. So you should have a minimum basic knowledge on Windows, Linux, SQLs, and Oracle DBA basic understanding. And on top of that, you should have a good hardware. That's your laptop or desktop with a minimum 20 GB RAM and 150 or 100 SSD hard disk. Right, so that is a minimum requirement. If you meet, then you should be able to catch up this course or able to understand. All right. So that is what we covered yesterday about the course duration, timing, and the fee structure. And again, we got couple of registration yesterday. If you're interested, again, feel free to ping me on my WhatsApp number or ping me on my email, or you can call me so I can guide you through further payment process and registration process. So I'm pinging here in the chat. You can take a note of that cell number or WhatsApp number or email ID. You can reach out to me if you have any further questions or you need a further clarity. All right. Right. So with that, that's the course duration, course timing, and the fee structure, what we covered yesterday, and followed by Google Drive and WhatsApp group. So very important. We have couple of students who are registered. They are already added to WhatsApp group. So this is a dedicated WhatsApp group only for the registered students. All the communications and all the questions or queries, everything will be discussed on this WhatsApp group. Again, not only related to this particular course, if you have any questions, queries, or you need any help or support on any of your tasks, if you are already working for any company and then you need some support or assistance on a particular task where you are stuck, feel free to use our WhatsApp group. You can post it over there. Anyone can help you on that, or I can connect with you one to one and I can help you out to unblock on that situation or on that task. Right, so that's about the WhatsApp group. So all the questions, queries will be using communication via WhatsApp group so that it will be benefited to everyone. So if you face like you attended any interview, you had some challenging questions and you are unable to answer, you can feel free to post those queries or questions in WhatsApp group. I will be answering to those queries or questions. So it is gonna be helping to you as well as it will be helping to other members in the group. So other member also will be having the same questions or queries. So with one definition, everyone should be get benefited, and it will be helpful for others too who are preparing for the interview. So we'll be always using WhatsApp group for any mode of communication as the primary source. Right. So on top of that, those registered students will be getting a Google Drive access. So we'll be having a link 1, 2, 3, 4. The link one where you have a course material, PPT, workbook, lab exercise, and other stuffs. In the Google Drive link 2, we'll be having the softwares, tools, and interview questions, automation scripting, and so many other advanced stuffs. And in the link 3 and 4, link 3 will be of previous batch recordings where you can go and then watch the recordings well in advance before attending the live classes so that you can do interact more during the live classes. You can ask more questions or queries. And link 4 will be the regular recordings. So if I quickly show it here, give me 1 second. So this is about the course material, the link one where you have various directories where you can see course materials, lab exercise, PPTs, and workbook. All those stuffs will be getting it over here. And there is a link too where the other information where you can see the DBA tool, softwares, interview questions, and monitoring script and automations. And the link 3 is for the previous batch recordings where all the recordings will be available here in this Google Drive. So along with the recordings, we'll be having a notepad. Let's say VM setup and networking, and we have this VM setup and networking for the same demo. For example, if I want to show the yesterday's one, what demo we recorded yesterday, so that also will be uploaded along with the notepad, what I covered. So let's say here, so this is the current batch recording. So yesterday we have conducted this demo session one. Along with that, whatever the notepad, whatever the command I executed, all those will be uploaded along with the recording. So whenever you watch the recordings, you can refer this notepad as well. Right. So whenever you're watching the recordings in the Google Drive, you can refer simultaneously that notepad so that you can execute the same command in your lab. Right. So that is about the Google Drive link and the WhatsApp group. It be dedicated to all the registered students. All right, that's it. So that is about the course what we discussed. Followed by we started with the few of the concepts on the rack architecture, rack networking, and rack installation, and advantages of standalone versus rack. That's what we discussed, and we wrapped up in yesterday's session. So let's continue today with the further discussion on the few more topics: the rack startup sequence, rack file system, OCR, OLR, and voting disk. So we'll take a few minutes. If anyone has any questions, I'll be pause for a minute here. If anyone has any questions so far or any queries, feel free to unmute yourself and ask, or you can use this chat here, Zoom chat. I'll be happy to answer those questions.
Malik Shiva here. Malik, as of now, people say that I never work on the rack environment so far. But generally, maximum how many nodes in real time they use?
In most commonly,
Practical, practical.
most commonly or regularly, like I worked with many customer meaning when I was with the Oracle, I used to work on Oracle engineering system. Oracle engineering system meaning Oracle Exadata, Oracle Supercluster, Oracle Solarize. So Oracle Exadata comes with a minimum like 2 node rack cluster, a 4 node rack cluster. We call it as a quarter rack. We call it as a half rack. We call it as a full rack. We used to get customers used to have the rack cluster with a 2 node, 4 node, and 8 node. Most commonly in Exadata, 8 node rack is widely used, 8 node rack cluster. And apart from Exadata, the other customer, when I worked for the other clients or when I was working for the other organization, Wipro or iGate or in EXA. So I have seen clients using uh, Oracle rack cluster between 2 node to 4 node. 2 to 4 is regularly used. Customer will be like 2 node rack cluster or 3 node or max 4 node cluster. What I seen it. Majority of customer. But the biggest cluster what I seen it in my career is 64 node. So one of the customer had 64 rack cluster node. That was the biggest what I seen it in my journey. And the biggest database what I seen was 1.2 petabyte. The database size is 1.2 petabyte, and there are many customers who has a database sizes varies from 200 terabyte to around 800 terabyte. So 200 to 800 terabyte, many customer have seen it, and the biggest database what I saw was 1.2 petabyte, and the biggest rack cluster what I worked was 64 node, and most commonly regularly customer uses rack cluster with a 2 node to 4 node. And in Exadata Oracle engineering system, many customers will be having 8 node rack cluster. Right. Okay, let's get started. If no questions, then the rack
Malik,
file
what?
system. Yeah, go ahead.
Hello.
Go ahead. Go ahead.
Malik, what is the system configuration for a real-time rack configuration? Like how many CPUs? What is the size of the RAM?
It depends
If it is
upon.
1 terabyte size,
No, it is not depend upon your database size. It depend upon your application connectivity, how application works, right? So nothing. Again, this is not that one we can easily define how much CPU, how much RAM, how much memory needed. It's all you need to understand how your application is behaving and how many maximum users are connecting and what is the transaction method. It's a OLTP or OLAP. You have to work with your application team and understand your application behavior, and based upon that, you have to define your database server resource. In a simple thumb rule, uh, this is going to be one of the interview questions. How much SGA, how much PGA you are going to allocate for a server or for a database? So we do not have any specific thumb rule, or we do not have any specific standard method. I need to assign SGA this much, PGA this much, and something like that. We don't have it. So it is all based upon your application and what purpose your database is configured. So in simple definition or the simple layman term, a book definition, it will go like this. So if you have 10 GB RAM, you have a server with a 10 GB RAM. So as a thumb rule, we'll go with the 80% for database. We'll go with the 20% for OS. So 80% for database and 20% for OS. And then out of this 80%, like 80% of 10 GB server RAM is going to be 8 GB RAM. 8 GB RAM you're going to allocate for your database, and whatever remaining 2 GB RAM you're going to allocate for your OS. 8 GB for database and 2 GB for your OS operations. And out of this 8 GB, you're going to allocate SGA and PGA. So you're going to allocate SGA and PGA, like SGA you're going to allocate 70 percentage to 80 percentage for your OLTP. So if it's a OLTP, like online transaction, your database is the online transaction processing database. So we'll allocate out of this 8 GB, 70% to 80% for your SGA, and remaining 30% to 20% we'll allocate for PGA. So if it is OLAP, the reporting data warehouse, so we'll allocate 50% for SGA and 50% for PGA. Because in OLAP, you need more PGA memory for query processing. We'll be running only select queries here. Here in OLTP, we'll be running many DML, DDL operations where you need more SGA. So that is kind of a memory allocation what we calculate based upon the thumb rule or the definition. But this definition will not hold good if you have many database running on a server or you have other application running on a server. Right? That is one simple definition what we can give as a simple layman term. But in real time world, will not follow this rule. We'll work with a application team and will understand like how we'll understand SG and PG and CPU, how we can define. So in a simple definition, a single user connects, he's going to use 3 MB of PGA. So default any user connect to my database, he's going to use a 3 MB PGA memory. So let's say 1000 users are connecting at any given time. So 1000 into 3 MB It will be like 3000 MB. Let's say approximately 3 GB. So 1000 users are connecting to my database at any given time. My application is a very busy application where I can see minimum 1000 users are connecting. So I need minimum of 300 or 3 GB PGA without any transaction. And I don't know how much big queries he's running, how much big transaction he's doing. Based upon that, I can add, okay, he might be running a big query where we need a 2 GB of PGA. So I can have 3 GB for to support that 3 or 1000 users and 2 GB for his transaction queries. So that itself made 5 GB he has my PGA. Then how many such big queries are running at any given time? So let's say 5 big queries I can expect at any given time. So 2 into 5, the 5 big queries that can run at any given time. So it itself become 10 GB here. 10 GB plus 3 GB, 13 GB PGA I need it for any given time for my database to support for those all the end user connections. Like similarly, you have to calculate for your HGA, how much of HGA and how much of queries they're running it. That's all not that so easy. So your solution architect or you have to work closely with your application team and understand how your application behaving and what are the maximum users were expected. Based upon that, we can define SGA and PGA. And again, same goes for your CPU. How many processing, how many users are running the queries, how many users are doing the transaction, what kind of a transaction they're doing it, and then how much of data it is pulling, and what kind of queries. Is it a similar queries they're running every time? Is it a new queries they're running every time? And how much of IO it is needed? And then how frequently we run a backup, and what how many channels we're going to use the backup. So considering all those things, we are going to define CPUs. How much CPU I need it? I need 8 CPU. I need 12 CPU. I need 24 CPU. So we'll go ahead and then define the number of CPUs. Right. So that is not that straightforward where anyone can go ahead and then define their SGA, PGA, CPU, or how much of storage I need it for my database. Whether I need for my database size of 100 TB, I need to go for my ASM disk groups, my ASM storage. Give me 1 second, guys. Give me 1 second. All right, sorry for that, guys. Okay, so now let's say my database is of 100 terabyte. So I need to predict how much storage I need it. So for 100 terabyte, my ASM disk group, what kind of redundancy I have it. So in ASM disk group, I may get external redundancy. I may get normal redundancy. I may get high redundancy. If it's external redundancy, I need whatever the database says, that much of storage I need it. If it's a normal redundancy, so it will be like 1 plus 1 copy. So if it's my database 100 terabyte, I need double of that. I need 200 terabyte storage. If it's a high ASM disk group, it will be 1 plus 2, one original copy and two duplicate copies. So I need a 300 terabyte of storage if my database is 100 terabyte. Based upon my redundancies, I need to define my storage. So this is for my database size and what is minimum storage needed. And then I need to predict how much my database is growing year on year. So I need to monitor this year how much database is grown, last year how much it has grown, and then I need to predict plus minimum of 10 years of my database growth. All right, sorry guys. So I need to predict what is the my database growth for 10 years. I need to add that much of storage, and then we never get any of the storage issues for the next 10 years. Like, storage space is full or my FRA is full. Those kind of issues we never get. Right. So that is again simple, straightforward definitions, but nobody can predict what is SGA, what is PGA, what is CPU, what is RAM, what is storage is needed on a fly. That's all needs your coordination with your application team and understand your database application and how many users are connecting, what kind of a transaction they are doing. Based upon that, we need to intelligently define the minimum SGA, PGA, CPU, RAM, and based upon that, how your database is behaving, and you have to take a call to gradually increase your SGA, PGA, and your CPU and the storage. Right. With that, let's continue for the further discussion. We'll get started with the RAC database file system. Right, let's take any more questions if anyone has before I take any sessions. Feel free to ask any question, not only like these are the free sessions, meaning on fly, like any questions or any queries not related to whatever I'm covering, whatever I'm planning to cover for today, or whatever I covered yesterday. It may be any questions you might have faced in your previous organization or current organization or any of the interview. So feel free to ask those questions, no issues. Right.
Yes, Malik. Which DevOps tools require mostly for the DBS? Because DevOps tools nowadays is I can see huge number of tools.
Right. So again, DevOps is too much. The DevOps tools, we don't need of much tools. Like DevOps, they will learn so many tools. Just example are Git, cookbooks, Chef, and other like installation process and all. So we don't need those kind of a things. We never use them for DevOps script tools. Like few examples, scripting. When it comes to scripting, so your Python scripting is very much important for the automation, or your Perl scripting or your shell scripting. So in DevOps, go ahead and then run the or learn scripting, very much important for a DBA to do automation. In DevOps, we have Ansible. Ansible scripting again. If you go and learn Ansible, you can do wonderful lot of automation like your database patching, your database upgradation, and many of the complex situation can be handled using this Ansible scripting. And we have Terraform. So if you are working on a cloud environment, Oracle Cloud OCI or AWS Cloud or Google Cloud GCP, we have different naming convention. So Terraform is the other mechanism or the tool where you can automate your cloud resources. So that is other form where you can make use of that. So that is pretty much what we need it. So scripting, you can go and learn any of the scripting and Ansible and the Terraform. So other than that, you have Chef, cookbooks, Dockers, and we have so many things, but those are like needs a complex understanding. It is all your interest. Uh, Especially like if you go with the Kubernetes. So again, very good at market Kubernetes. So that needs your complex understanding of the networking and other fundamental stuffs for the cloud. But for now, as a DBA, I'm not interested to completely move to DevOps, but I need my DBA day-to-day job to be, automated. Then go for this minimum, uh, at least not Terraform, Ansible, and then scripting, Python or shell scripting or Ansible scripting. You can do many automations by learning this. All right.
Yeah, yes. And scripting, shell scripting and Python, I'm much aware. Perl means that is, it is in Windows scripting or in Perl is different language. Can you what it is?
All the Oracle uses Perl scripting. Whatever the script we run it in the Oracle, all backend will be Perl scripting. So again, these are old technologies. If you understand, then you'll do some more automation. So again, that is also kind of a scripting. So
Okay,
if
okay.
I'm talking with respect to only Linux, if you are working for the Windows environment and go for your PowerShell. So PowerShell scripting is also very much needed for DBAs if you're working for Windows. So if pretty much Windows, we use PowerShell and again do a lot of things in the PowerShell script. All right. Right, let's quickly get onto my lab, quickly understand the file system. Right, so what I'll do now, different file system, like now let's go to the basics. I think you all from the DBA background, you know the database architecture, database fundamental foundation. My database startup sequence goes like this. Shutdown, from shutdown to no mount, no mount to mount, mount to open. So that is my a typical database startup sequence. From shutdown to no mount, we're going to read SP file or P file. We're going to read this SP file and P file. My database instance will get started from shutdown to no mount. From no mount to mount, we'll have a control file. That control file will be mentioned in this SP file or the P file. My database will go from no mount to mount. From mount to open, my database will read all the data files and all the redo log files, and my database will get opened from mount to open state. So this is my typical database startup sequence. So what it indicates here, in order to start my database, I need SP file or P file, I need a control file, I need a data file and read log files. Without any of these, your database or your database instance will never be get started. So very first thing is SP file. So in case of a standalone, let's go back here. In case of standalone, my database instance and my database, it's all one-to-one mapping. We need one SP file, one P file, one control file, one set of data files, and one set of read log files. All will work here. In case of RAC, do I need one SP file or three SP file here? Do I need one P file or do I need three P file? Do I need one control file or do I need a three control file here? Do I need one set of redo log or three set of redo logs? Do I need one set of data files or I need a independent one? Instance one has the data file, instance two has data file. How is the files are shared between these instances, or each individual instance has its own files? That is shared and non-shared. Shared and non-shared. Is your file systems, is your files are shared or non-shared? Let's go with the SP file. We'll be having SP file. Let's say my database is DevDB, which will be having here. Let's say I have this host node, my RAC cluster, Let my rack cluster, host 1 and host 2, where I have this DevDB database, where it has DevDB instance 1 and DevDB instance 2. So I have this SP file. SP file should be SP file devdb.ora, which will be shared between instance 1 and 2. Only one file. I'll be having only one SP file. Both instance 1 and instance 2 will be using single SP file. My DevDB instance 1 and DevDB instance 2, and then we'll be having this shared storage. So both are SP file. We'll be using that single file, which is available in the ASM disk group. So this SP file will be shared. The moment it is shared, placed in ASM storage. It will be under this ASM storage. For example, if I can quickly go here, DevDB instance 1, srvctl config database -d devdb. So I have this data devdb parameter file and SP file. So that will be, this is the file number and this is the ID what ASM is going to generate. I'll go to my ASM storage, ASM cmd-p. Again, this is your ASM storage. Anything start with a plus, that's ASM storage. You have to go to ASM command line to take a look on that. So this is my SP file, which is stored under ASM. So single SP file is used or referred by both instances. So standard naming, you can go with the SP file devdb.ora, or you can give it to ASM to define whatever the name it wants. P file, let's say we talked about, we'll go with a simple definition here, shared and the standard name should be SP file devdb.ora placed inside ASM. And the P file is the non-shared. And non-ASM, meaning we'll be having P file that will be in the form of init devdb1.ora and init devdb2.ora, and which will be located, placed on OS file system. Under that, in straightforward, it will be under Oracle home /DBS. It will be under that individual Oracle home DBS location. Both init file will be stored. It is not on ASM. That's why non-shared, non-ASM. So if I go here for the node 1, cd u01 app Oracle product 19c db home 1 dbs. So lsf and ltr init dev. So right now we don't have a dev, we have a devdb. So I can quickly create a P file from that SP file, devdb1. Right now if I do show parameter SP file, so I have this SP file, whatever we just saw, which is under ASM disk group for this devdb database. So if I go to second node, or I can put it in two terminals side by side. Right, so this is my node 1 and this is my node 2. DevDB instance 2, DevDB instance 2, SQL plus slash as DBA. If I do show parameter SP file, so again the same SP file, meaning SP file is inside ASM and which is shared between both instances. So I'm just going to create P file from that SP file. And again, I'm going to create a P file from SP file here. Now I'll log out from here. CD $oracle home slash DBS on node 1 and I'll go into node 2. So if I do ll init devdb, so this is my devdb 2 instance 2. Here it is init devdb instance 1. So both the devdb instance 1, devdb instance 2 specific init file, which will be located under independent of that nodes, individually on node 1 and node 2 under DBS location. So that is non-shared. P file is non-shared. You cannot keep your P file inside ASM. P file is a text file. ASM will not support for the text file. ASM will support only for the binary file. Your SP file is a binary file. That's why you're able to keep your SP file inside your ASM storage or ASM disk group. Again, ASM storage, ASM disk group, those are the terminologies we regularly use it. Again, in our regular RAC class, you'll understand more on those. But for now, just take ASM is a storage. So that will be init devdb1.ora, init devdb2.ora, which is a non-shared and non-ASM. And next, once we use SP file or P file, we'll start the database instance in no mount. And from no mount to mount, we're going to go into control file. Control file is shared, right? Shared and ASM, placed under ASM. It is non-shared and non-ASM. Your control file shared and ASM, placed under your ASM, meaning both the instance 1 and instance 2 accessing the same control file. If I go to node 1 here, connect back, select name from $, control file. I have this control 1, control 2, which is placed under data and reco. Same thing on this second node. I have same data reco, control 1 and control 2. So two control files are placed over here. Right, so both are shared and placed under ASM storage. Right, so again, standard naming will be control.ctl. So we will placed in ASM storage. So we have something called multiplexing control files. Multiplexing control files meaning instead of keeping one copy of control file, we are keeping a duplicate copies. Because if one copy is corrupted or crashed or deleted, you still have another copy to sustain your database. Your database is continuing to run. That's the multiplexing of control files. Right, so SP file, P file, control file, and in a simple definition, your SP file is a binary file, and your P file is a text file, and your control file is a binary file. And after these three files, next comes your data files. So data files, like let's say shared and non-shared. Your data files are shared and non-shared. Very interesting one. And you can keep your data file on ASM as well as you can keep your database on non-ASM. Nobody is stopping you. You can keep your data files, some of the data files on ASM storage, some of the data file on non-ASM storage, and you can keep some of the data files are shared between your both the rack instances, some of the data files are non-shared. All are supported here. So let's go with all of them. System dot dbf, sysocs dot dbf, and temp dot dbf, users dot dbf, undo 01 dot dbf, undo 02 dot dbf. So we have this data file. Let's go here. Select name from VDollar data file. So we have system, sysocs, users. System, sysocs, users. For the temp file, we'll not be querying this VDollar data file. We'll be querying select name from VDollar temp file. Temp file is a separate file. You have to query VDollar temp file to get that temp. So same thing if I run it here in the second instance. So we have system, sysocs, users, undo 1 and undo 2. Again, temp file. So what it indicates, my temp file is a single file shared between both instance 1 and 2. My system, sysocs, users. System, sysocs, users. Or again, single data file shared between instance 1 and instance 2. But once we consider here undo TBS1 and undo TBS2, we have two data files for undo. Why two data files? Because those two data files for instance specific. Undo TBS1 data file is for DevDB instance 1. Undo TBS2 data file for DevDB instance 2. So you might be aware why we need undo. Any user do any update transaction, old value will go into that undo data file. Let's say user 1 connected to data file DevDB instance 1, he do some update statement. All the old value will go to that undo data file which belongs to that instance 1. So client 2 connected to your instance 2, he is also doing some update statement, and old image copy, old value will go into this undo data file 2. So this undo is instance specific, and which is you can keep it under ASM or non-ASM, or you can keep it under instance specific. That's why some of the files are shared between both instances, some of them are non-shared, and some of them we can keep it under ASM storage, or some of them we can keep it under non-ASM storage. So let's say now I can say shared and ASM for your system is a shared one. Users also shared one, and this one is non-shared. Is a non-shared, and you can keep it under ASM or non-ASM anywhere. But usually we'll go with everything under ASM storage for my database. All right. So that is for your data files. After that, what we need? Redo log files. So again, these all data files are binary files. Whatever these data files are all binary files.
Your voice is breaking. You are not audible.
Give me a second. Why?
How about now? Can you guys hear me?
Yeah, now it's audible. Yeah, now it's audible.
Sorry, maybe some network glitch. Okay. So what I was talking here, I think so far so clear, right? So all data files which are saved, not saved, what I just covered. Now redo logs. So let's say select. I'm just going to describe VDollar log. So I'll say select group number, or instead of group number, let's go with the thread. Thread meaning instance 1 or instance 2. Thread number, that is your DBDB instance 1 or DBDB instance 2. Group number, and then members from VDollar log. Right. So what it says here, so it says this one. I'll run the same query on the second node here. So I have a thread 1, thread 2, meaning DBDB instance 1 and DBDB instance 2. Again, same thing, DBDB instance 1, DBDB instance 2, which has redo log group 1 and 2. Redo log group 1 and 2 belongs to my DBDB instance 1. Redo log group 3 and 4 belongs to my DBDB instance 2. Meaning both instance 1 and instance 2 has its own individual redo logs. Let's say here we have 2 redo logs, and here we have 2 redo logs. And this instance 1 will be interacting with this redo logs, and instance 2 will be interacting with this redo log. This is a group 1, group 2, and group 3, and group 4. So my DB instance 1 will be writing on group 1. When this group is full, you'll go to group 2. When the group 2 is full, it'll want to write back to group 1. And again, group 1 is full, you'll want to go back to group 2. So group 1 and 2 will be used by my instance 1. Group 3 and 4 will be used by my instance 2. When this DB instance 2 will be writing to redo log group 3. Once that is full, you'll go to group 4. Once the group 4 is full, you'll go to group 3. You'll be switching between the groups 1 and 2 and 3 and 4. So each of those group 1, 2, 3, 4, all of them will be having a 2 members. One member is enough. One file under each group is enough. But why 2? Again, that is called multiplexing. In case of one redo log is corrupted in a group, you have other copy to sustain your database. Right? You can get it using describe VDollar. Give me a second. All right. Describe VDollar log file. Sorry for that. Select group number, comma member from VDollar log file, order by group number. Set pages, lines. Here also I can run select set pages, lines. Right. So let's say here, what we understood here, We have DevDB instance 1 has a 2 groups. Each of the group has 2 redo logs. And DevDB instance 2 has 2 groups, 3 and 4. And each of these group has 2 redo logs. That you can see here. Group 1 has a 2 redo logs. One is under reco and one is under data. And my redo log group 2 has a 2 redo logs. One is under reco and one is under data. My redo log group 3 has again 2 redo logs. My redo log group 4 has again 2 redo logs. So these redo logs are instance specific. So redo logs will be like this. Redo 1.log and redo 2.log. So which will be which will be non-shared and in ASM. Redo log 1 and redo log 2. Just I'm giving example. Redo log 1 and redo log 2 belongs to my instance 1. Redo 3.log and redo 4.log. Again, I'm talking about the group 1, group 2, group 3, group 4. Inside that, we have multiple logs. So these are binary files. These redo logs are binary files. You cannot open anything binary files. You cannot open and you cannot read it. And these redo logs are called redo log multiplexing. Why redo log multiplexing? Because if one redo log corrupted, you have another redo log to sustain your database, to keep the consistency of your database. Right. On top of that redo log, we have so many other files like archive logs. So archive logs are nothing but copy of these redo logs. Archive logs are saved. Your redo logs are non-saved, but your archive logs are saved and on ASM. Both archive logs, both instance will generate its own archive log, but both instance can use and both instance can read and write, which is saved. Again, it is under archive logs. Again, these are binary files. And standard naming convention ends with whatever that thread1.arc, thread1 and some numbers will generate some number and then arc. Again, these archive logs are binary files. So your redo logs are non-shared, non-ASM, and on top of this redo log, we'll generate this archive log, which are shared and which are on ASM. Archive log list. So it says use DB recovery file list. So if I do show parameter recovery, so we have this reco disk group. So I'll go to reco dot .inv plus asm1 asm cmd -p cd plus reco ls-l. So go into the dev ls-l. So archive log, go with the today's date. (2024) today's date. Give me a second. Give me 1 second, guys. Alright, sorry guys. Let's go with the 4th, 5th. We don't have a archive log. Let's go with any one of that. I'll go with the latest one here. So thread sequence 1 or sequence 2 generated with archive log from instance 1 and instance 2 and some sequence number and some ASM related names here. So same thing, you can get it from your other instance here, plus ASM2. So it'll be a same storage, ASM CMD-P. So we'll go with the same location. Is it still, my voice is not audible?
No, it's audible.
All
It's
right.
fine.
So yeah, somebody is pinging in the chat here, voice is not audible. Can you just rejoin again? Right. Your archive logs are shared and which are on ASM. Both the DevDB instance 1 and instance 2 will share and use the same archive log generated by instance 1 and instance 2, doesn't matter. And again, these are binary files. All right, so those are pretty much your backend files.
Malik sir, Shiva here. Sorry
Yep.
to ask you. This reload log you said it's non-shared as well as non-ESM, right?
ASM.
ESM, okay.
You can keep your read log in non-ASM as well, local file system also. Default, you're gonna go with ASM, but no restriction. You can keep it in non-ASM. It works fine. Great. Now we have so many other files. Let's talk about password file. Password file is shared and ASM. This is shared between your instance 1 and instance 2, and which is placed under your ASM. You can get it here. .env devdb1 srvctl config database -d devdb. So we have this password file, data devdb password and password. If I go here in this ASM storage lsfnl, so this is my password file, which is only one password file, which is shared between both instance 1 and instance 2 and placed under ASM. The standard naming convention will go like this: pw devdb, that's the standard name, and followed by your pwd and devdb and followed by your ASM name. So this is again binary file. We cannot read or we cannot check what's the content of that. Right. So these all files pretty much we keep it under ASM storage, except this SP file, except this P file, SP file, control file, data files, and redo log files and archive log files and password file. Pretty much we will store all of them into ASM. And other than that, whatever files we are getting here, let's say maybe alert log, trace files, TRM files, incident files, core or dump files. These are diagnostic files. So these are like diagnostic files, alert log files. Like we'll be having alert underscore devdb1 dot log, and we'll be having alert underscore devdb2 dot log. And trace file, my instance 1 will generate its own trace, my instance 2 will generate its own trace. My TRM file, my devdb instance 1 will generate its own TRM files, my devdb2 instance will generate its own TRM files. My incidence file, again coming from my devdb instance 1, coming from my devdb instance 2, my incidence, code dump files and all those things, all diagnostic files. These are instance specific, meaning placed on non-ASM. Give me 1 second, guys. All right, sorry for that, guys. So these are like diagnostic files, alert log files, trace files, TRM files, incidents, core, dump files, and all those things, which are placed under non-ASM. Means locally. Let's say I'll go here, node 1, locate, alert, underscore, devdb1.log. So I can see my alert log, ll alert, located under this OS file system. Same thing on your second node. Locate alert underscore devdb2 instance2.log. So which is again located over here on the OS file system, second node. Right, on top of that, whatever the trace and TRM files here, node 1 specific, instance 1 specific, all these trace files, TRM files, and here your second instance, devdb2 instance, specific trace files and TRM files. Right, so that is called your diagnostic file. Any instance related issues, instance 1 crashed or instance 1 is not starting or anything on the instance 1. So we'll go and then check for the respective trace files and the TRM files, alert log, incidence files. That's why we call it as the diagnostic files, which are placed under non-ASM, local file system, and non-shared. These are not shared one. Independent of each instance of my RAC database has its own files. Alright, so that is pretty much what I wanted to cover under a file system, which are shared or non-shared. So any questions so far before I move to the second topic about this file system structure and how they stored? Right. We'll take it as a no. No questions.
Yeah, if redo log is non-shared, then how archive log is shared?
Your redo log is non-shared. Let's say you have redo log 1, you have redo log 2, and user 1 is done some transaction, and the transaction is written to redo log 1. Redo log 1 and redo log 2 is here. Redo log 3 and redo log 4 is here. We have something called instance recovery. So let's say this user done some transaction, some update, and we know that redo log will gonna do the moment user do a commit, whatever, like we have memory architecture. Again, you might be aware in your database basics, we have database buffer cache, we have log buffer cache. So transactions will be returned to log buffer. From the log buffer, we're going to write that transaction to redo log the moment user do a commit. So my instance 1 has crashed. The moment the user do a commit, this redo log will be returned to its archive log. So in order to recover your instance 1, make your database consistent, your instance 2 is going to read that redo log or is going to read that archive log to make your database in consistent state. Even though each of this instance 1 and instance 2 will generate its own archive log, but your instance 1 can read the archive log generated by instance 2. Your instance 2 can read the archive log generated by instance 1. So that's where we call it as a shared one. Because your instance 1 crashed, the recovery of the instance 1 will be done by your instance 2. That's where we call it as the instance recovery. Right, so simple definition here. Many people will get confused. One is crash recovery, other one is instance recovery. So crash recovery, we call it as in a standalone environment. Instance recovery, we call it as in a RAC environment. Right? In case of standalone single instance, if the instance crashed, When you start the instance in the next time, that time SMON will read that redo log or the arclog and then perform your crash recovery. We call it as a crash recovery in case of standalone environment. In case of rack environment, when the instance is crashed, we call it as an instance recovery, meaning instance 1 is crashed. The recovery of that instance 1 will be done by instance 2. That's where we call it as an instance recovery in case of rack. During that recovery, your instance 2 will read that redo log or the arclog of instance 1 and then perform the recovery and make your database inconsistent. That's why we call arclog as a shade between both instance 1 and instance 2. Even though both instance 1 and instance 2 will generate its own arclog, those are needed for in case of crash. All right.
Okay, thank you. And can we change extension of redo log from dot log to any other like dot .bak or dot
You can
.dba
keep whatever name you want. You can keep dot
by
Malik
altering? Right?
while adding the redo log file. So adding a new redo log, you can add Malik dot Oracle. You can keep Malik dot India, Malik dot Bangalore. In ASM, extension does not matter. It's just a binary file. You can put whatever extension you want. Right.
And after changing, what about previous one?
Drop them.
Earlier one it was dot log and I changed to dot .dbf. So what about the earlier one?
Drop that one. After adding a new redo logs, you can drop the old one. Delete the old one. And that is not a simple go and then remove it. You want to change your redo log files name, you want to change your data file name, you want to change your control file name. It has certain step of procedure you have to follow it. Right? So control file rename, you cannot directly go and then do online control file rename. No, it's not supported. You have to add a new control file and shut down your database and remove your old control file entries from your SP file or the P file. You want to change your data file name, it's not that easy. You have to use move, online move command. In 11G, it is not supported. You need a downtime. But in 12C nodes, you can do online rename, alter database and rename or move whatever the old name to new name. And redo log files, you cannot do a rename. You have to add a new redo log files and then drop that old redo logs. And control files, you don't have any option to rename or move your control file online. It needs a downtime. So it has set up procedure for each of these activities. But it can doable. You can do it.
Okay, thank you.
All right. So let's quickly take a look on that.
Malik Hanmant here.
Yeah.
I actually, in case of table space full, or if you are taking Arman backup, in which alert log we will get the information?
Table space is full
Yeah.
while taking RMAN log. Why RMAN log and table space will comes here?
In alert log, we will have information, right? The backup is going on. The table space is full.
No.
Actually, in which alert
No,
the first instance?
we don't get that table space full and all those information. Alert log is only for your time-based incidents. Anything happens in your database, then you will get alert. Like any critical error occurred in your database, any VARA error is occurred in your database, your FRA is full, and your ASM disk group is full, and only those kind of VARA errors and the timestamp will be located in your alert log. Your table space is full and user does not have any privileges, those will not be noted in your alert log. Right?
Yeah, what I'm asking is it right in both alert log or it writes only the
No, once again,
instance?
you are talking about your table space is full. We never ever write, Oracle will never ever write table space full or empty or user has a permission or not. All those information will not be written to your alert log. Alert log is only for diagnostic log. Any critical error occurred in your database, only those error will be reported. Table space full is not an error.
See, if you get ORA 600, in which alert log it will be written?
ORA 600 is,
Instance 1 or instance 2?
again, the ORA 600 is occurred where? That's the instance specific. What error code is? If user 1 is connected to instance 1 and then he's doing some transaction and then his PGA is exceeded his limit. That error will be reported on instance 1. And any user connected to instance 2 and he's doing some transaction and the transaction failed or his session terminated or whatever happened, and then the error will be reported on that specific instance alert log. Right? That is instance specific, where they're connected and what transaction they're doing it.
Okay, good. Thanks.
All right. Quickly, the maintenance, I want to do some maintenance. So database maintenance, I'll use SRVCTL, and my ASM maintenance, I'll do SRVCTL, and I do cluster maintenance, I use CRCTL. Right? Database, ASM, cluster. So for database, let's say this is how it goes. Each of this node, we have cluster, and then we have ASM, and we have database hierarchy. So if you do anything on the database side, you can do maintenance of your database, which will not touch anything on database or the ASM or cluster. Fair enough. If you do any maintenance on ASM, the moment you do maintenance ASM, your database will go down. Right? Because on top of cluster, your ASM is running. On top of ASM, your database is running. So you have to be very careful where you're doing maintenance. Maintenance you're doing on the database side, fair enough, you can go and do it. The moment you're doing maintenance on ASM side, make sure that your database needs the downtime for that. If you're doing any maintenance on the cluster side, make sure that your ASM and database going to be down. So we have two options. Let's say give me a second. Right now, let's say I want to do maintenance of my database. Whether you want to do maintenance on both the node 1 and node 2. I have two nodes, like I have node 1 and I have node 2. You're doing maintenance on only this instance 1 or instance 2, your database instance 1 or database instance 2. Give me 1 second, guys, 1 minute. All right, guys, sorry for that. Okay. You're doing a maintenance on only instance 1 or you're doing a maintenance, sorry, this instance 2. You're doing a maintenance on both the instance 1 and 2. You have to be very careful on that. Let's say you're doing maintenance on instance 1, shutdown. I'm going to use srvctl stop instance and -i devdb instance 1 and -d my devdb database. For this devdb database, I'm shutting down my instance 1. And similarly, it goes srvctl stop instance devdb instance 2 for my devdb database. So I can go ahead and then check status, and I can do start instance 1 and instance 2 for this devdb1 and devdb2. So once this is done, I want to go for my entire database maintenance. Instance 1 and instance 2, I need to stop it together. All right. DevDB1 and DevDB2, both the instances I want to shut it down. So I can do srvctl stop database -d devdb. I can do check the status of my database. I can do start my database. So this is entire database wise. Both instance 1 and instance 2 together will be brought down. So meaning for my database, I can do instance specific shutdown and startup using this srvctl, or entire database specific shutdown and startup, I can do it. But whereas ASM, it's a node specific. I don't have option to shut down my both the ASM instance 1 and 2 in together. So I'll just do srvctl stop ASM, srvctl config ASM, srvctl start ASM. Right, let's say plus ASM1. So I can say srvctl config ASM. So I'm going to tell you my ASM information. So if I do status and if I do check, so before config, let's go with status if that is confusing. So right now here, the difference between database and ASM, we use the same srvctl to maintain or administrate my database and ASM. But for the database, we have instance specific shutdown and startup option and database specific shutdown and startup option. But whereas ASM level, I don't have that plus ASM1 or plus ASM2. You have to go to node 1, shut down your ASM or start your ASM. If you want to shut down both the ASM instance 1 and 2, go to ASM node 1 and do this stop command. And go to your node 2 and then do the stop ASM command. There's no instance specific. Even though these commands are instance specific, you have to go to that node and then execute it without passing any instance 1 or instance 2. It is not like your database specific. Then, whereas my cluster is similar to my database, I can go with the node specific or I can go with both the node specific. So first I'll go with the node specific, crctl stop crs on node 1, crctl check crs. Let's go here. crctl check crs or crctl start crs. So again, we don't have crs 1, 2, 3. We don't have. If I want to shut down node 1 cluster, I need to connect to node 1 and run this one. You're gonna shut down your ASM, you're gonna shut down your database. If I want to shut down on node 2, I have to go to that node 2 and then do the stop CRS and start CRS. And then all the node 2 cluster resource, everything will be stopped here. Like similarly what we did here for database instance. Similarly what we did for ASM instance. But how your database is supported here, shutting down your database instance 1 and instance 2 together using this command. Same thing you can do it using clusters command. You can do this crctl stop cluster -all crctl start cluster -all crctl check cluster -all. So that's going to give you all the cluster wide stop and start option. Both the nodes, your cluster will be down using this cluster all option. Right? So I can quickly check my database status for a quick demonstration here. DevDB1. My DevDB database 1 and 2 running here, both the nodes. So if I can stop my instance 1 alone, I can run srvctl stop instance, my DevDB instance 1 and my database name. That'll going to shut down your instance 1 alone. It's not going to touch anything on the instance 2. This is going to take a few minutes. Right, any questions so far? Let it go on at the back end. We'll take few questions anyone has so far.
Yeah, hello.
Malik, Anmant here.
Yeah.
Hello.
Yeah, go ahead.
Yeah, if I connect to instance as SQL Plus, if I do the shutdown, it will shut down the instance or both the instances.
Which instance you are connected? You are connected to node 1, you are connected to node 1 instance.
Yeah, if I connect it to node 1, then I issue the shutdown immediate.
That going to shut
It
down
will
that
bring
instance
down
1.
both the instances.
Instance 1, where you connected.
Okay, it won't bring out the database.
Right.
If I wanted to bring down the database, I have to use a service detail only, no other options.
You have to connect to both the instance 1 and 2, do shutdown on both instance.
Okay.
Let's check the alert log. Right, it says the moment you see your stop command is taking more time, then you should understand there's something wrong. The moment I checked here in the alert log it says my FRA is full and I cannot do any more archive generation and my database is not allowing me to go down. So I can quickly go and then clean up my archive logs from the other node. DevDB instance 2 armand target / delete archive log all. There are a lot of archive logs running from so many days. Let's go and delete them. The moment I delete the archive log, my database shutdown is went. We're going to proceed further here. Right, archive logs are deleted. My FRA is cleaned up, and your database will go now. All right, it's going to take few more seconds since right, my database shutdown initiated because it's able to generate the archive logs, and my background processes are going down.
Malik, I'm Nagarjuna.
Yeah. Good.
Yeah, normally we don't database like shutdown immediate on DB level, right? Database level.
Right.
Here you given the command like srctl stop instance. So without down the database, we can do it, or with down
Come
the
again?
database.
No, come again.
Normally to down the database, we give the command like shut immediate.
Right.
Shutdown immediate.
Right.
Whereas here you are going to down here instance, right?
Right.
Like stop instance. So here in the first we have to down the database before going to down the instance, or directly we can stop the instance. It is good practice or bad practice.
No, there again you are missing some basics. We are not shutting down database here. We are shutting down only instance. Like what is that?
Okay.
You have your node 1, you have node 2, you have your instance 1 running here, and you have instance 2 running over here. 2 instance you are
Okay.
running, and your database is saved under this ASM disk group here. Your database is here. You are shutting down
got it.
only this instance 1. Your instance 2 will be accessing your database.
Okay, what are the users connecting? They are switched to this node 2, right?
Right.
Connection switch all. I have one more thing. While the instance is down now, the application end, they are hitting any query like select query or update or delete something, DML or operations, DDL operations. So when we are down this instance, is it the application will move to the node 2 or anything failure will happen?
That's
this case?
what we discussed yesterday, right? Like we have all the users who are connected here. The moment you shut down this instance, all these users will connect to your other instance.
Okay. But while when attending entry call, they ask me the same question. Like we are directly stopping the node 1, like this instance. Is it all type of queries will like select or DML operations will be
Only select
switch
query.
over. Only select will be switch over to this one, right?
Right.
Node 2 or node 3. Okay. Thank you.
Failover supported with only select queries. If customer is doing any select queries, they fail over to other nodes.
Okay, got it.
Any insert
Malik, how you can find out the master
update.
node? If in case
Give me-
4 node,
give me-
which will
give me
be
a
the
sec.
master?
Give me a second. Any user connected to node 1 here now and he's doing a select query, that's gonna fail over to other node. Let's say he is extracting 1 million record. Out of 1 million record, he extracted 0.5 million record, and then
Okay.
node 1 goes down. Automatically, his sessions will be connected to instance 2 or instance 3, and he will continue from where he has left out. Select query will fail over. Anything other than that, insert, update, delete, or any DML query he run it, only his session will fail over. Meaning,
Okay.
out like he's doing insert 1 million record. Out of that 1 million record, he inserted 0.5 million record, and then his node 1 terminated or node 1 crashed, and his session will automatically fail over to the second node, and whatever this 0.5 million record is inserted, everything will be rolled back, and he has to re-execute that query from the scratch again.
Okay, clear.
Right? Only the select will continue from where it has left out, but for any other than select, he has to re-execute that query, but his sessions will be failed over.
Okay.
Right. Yeah, somebody has a
Thank you.
question.
Malik, for that case, scan will fail over, or we need to do the
We
TFA,
talked.
transparent application for.
Yeah, there's a different story we talk about that. Yesterday we told failover will be helped by your VIP. We will discuss in further how. That's you're asking how the failover happens. That's the internal you have to understand first. We'll discuss in our regular class. Right.
Malik, one more thing. How we can see which is the master node?
Again, this is too early
On
to discuss all this master node.
okay.
We'll
Okay.
discuss in our regular class. There are multiple way to discuss or multiple way to get your master node. Using your CRST log, you can get it. Using that O columnar command line direct, you can get the master node. So there are multiple ways you can get it. It's a simple one. Right. So your instance is down now here. Status right now DevDB1, which is not running. So you can go and then stop your database, entire database. It will be like shutting down your both the instance 1 and instance 2. Instance 1 is already down here. We already brought down. SSD stop database. You are stopping your entire database, including both instance 1 and instance 2. Right, let it go on. PSF grep smon. So here also your instance 2 is already down. Right, check the status of your database, entire database. So your database instance 1, instance 2, not running on node 1 and 2. It's down, completely down. You can go and then start it. Entire database, SSD start database, meaning it's going to stop your both instances, node 1, instance 1, and node 2, instance 2. Both will be started. This is the database wide maintenance, and these are your instance wide maintenance. And again, these are your node specific ASM maintenance. If you run this command, only on that node 1, your database instance will be down. Your ASM instance will be down. The moment your ASM instance is down, underlining whatever the database instance running on that node will be down here on that node where you are running this command. If you want to down both the node 1 and node 2 ASM, you have to run this command on node 1 and node 2. and ASM instance on node 1 and node 2 will be down. The moment ASM instance 1 and 2 is down, whatever the database instance running on that node 1 and node 2 will be goes down automatically. Status here, now you should have your DevDB instance 1 and instance 2 will be running on both the node 1 and node 2. Right, now quickly check on the ASM level. SSD stop ASM, start ASM will be done it on both the node 1 and node 2. We're gonna stop that node 1 and node 2. And if I do stop CRS, that's gonna stop that entire node 1. So in order to do that one, you have to set the environment to plus ASM. CRSTL stop CRS. So if I want to do stop CRS, it's gonna say that this command needs some super privileges. Right now you're running it as a Oracle user, which is a insufficient privileges. So this is the common questions many of my previous students or my friend circle, they will be using, like they will be asking, which all command I can run with the Oracle user, which all command I can run with the grid user, when to use a CRSTL, when to use a SRSTL. Again, there is no standard definition or thumb rule which command can be run with which user, and when to use a CRSTL and when to use SRSTL. There is nothing fixed rule or definition. It all comes based upon your experience, how much you do hands-on, how much do you do practice, and then you will be able to understand. So I'll just jump to root user .env plus ASM1. So I can quickly see CRSTL stat resource -t. So right now, let's say here I have a scan 1, scan 2, scan 3. Let's say I have this node 1 VIP, VIP1 running on node 1, VIP node VIP2 here running on node 2. I have this scan 1, 2, 3. Scan 1 is running on node 1, scan 3 is running on node 1. Like scan 1, scan 2, scan 3. So which is running on node 1, which is running on node 2, and then which is running on node 1 again. Like right now, let's say I have 3 VIPs. These are VIPs, scan also VIPs, and node VIPs also VIPs. We discussed yesterday this networking. Right now, these are the node 1, node 1, node 1, because 3 VIPs, node 1 VIP, scan 1 VIP, scan 3 VIP. These 3 are running under node 1. The moment I brought this cluster down here, CRSTL stop CRS, you can use -f force option. That's gonna forcefully, like even if any process is waiting, you're gonna forcefully shut it down. The moment I shut it down, all this node 1 VIP, scan 1 VIP, scan 3 VIP, all will fail over to your second node. And any user connections and all automatically failed over. Right, let's say I'll go to second node here. .env plus ASM2 CRSTL stat resource -t CRSTL stat resource -t. So right now you see here node 1 VIP started on node 2. Right now node 1 VIP earlier, this was the node 1 VIP here, which was running under node 1. Now it automatically failed over to your second node. And you have this scan 1 automatically failed over to node 2. You have this scan 3 automatically failed over to node 3. So these VIPs are like floating in your cluster. The moment one of the cluster node goes down, automatically they will shift to your second node, and then all the transactions will continue to run from there. All right. So your cluster is down here. So still going down. Few more services to stop. All right. So with that, I'm gonna stop it for now. I'll wrap it up for today. If anyone has any further questions or queries, I'm happy to take it. Otherwise, we'll wrap it up and we'll continue in our regular classes starting from next weekend. Right. Any final questions or queries anyone has?
Malik, Anmantya.
Yep.
Actually, in a production environment, you don't have access to the root, right?
Yeah, you should have. Any DBA working in a RAC environment, you will be having a sudo access to root for that Oracle user.
So we need to run all the crstl command through root user.
No, only few command. Again, I just told there is no standard definition which all command can be run with root and which all command can be run with Oracle or grid. Only the stop commands needs a root user. Other than the stop, the check, maintenance and all, you can do it from Oracle or grid user. Any 4 questions, guys, before we go off?
What will be the best practice to shut down the database? First, we need to shut down immediate. Like first need to shut down the database, then in instance like srvctl stop instance.
Your whatever we're doing here, stop instance, the stop instance will use srvctl stop shut immediate. That you can get it from your database configuration. What configuration you have done it? Let's say in my database here, you do srvctl config database -d devdb. If I devdb, okay, cluster it down. I'll check it on second node. .inv devdb instance 2. So my configuration for devdb, it says whenever you do stop, it will be a stop immediate. Any of these command you run it, srctl stop, start, instance wise or your database wise, any of these command you do here, these all gonna shut down gracefully. You're gonna do stop immediate or shut down immediate. But whereas when you shut down your ASM, that ASM will internally shut down your database instance. Because what I told, it will be like this. Cluster, on top of the cluster, you have your ASM. On top of ASM, you have your database. Same thing here on second node, cluster, on top of that ASM. On top of that, you have database instance. You do anything on the database instance level or database level, shut down and start using this command here. All this command will use your shutdown immediate option. Other than this database level command, if we use ASM command will do shutdown abort. Other than this ASM, if we do cluster level stop, they'll do shutdown abort. So right now we ran this command here, crctl stop cs command. So I shut down my node 1 here. I shut down my node 1 cluster. That cluster internally brought my ASM down, and that ASM internally brought my database instance down. This is database instance is shut down abort. So which is a bad thing. So best practice is always you do shut down your database manually. That database shutdown will be of shutdown immediate. After that, you can shut down your cluster. Otherwise, you can end up with directly you can do shutdown cluster that will end up with shutdown abort all your database instance, which needs your instance recovery for the next time startup. All right. With that, let's wrap it up, guys. Let's continue further in our regular classes starting from next weekend. Again, if with that, if anyone interested or continue to enroll for this course, feel free to contact me on my cell number or my email ID or WhatsApp number, and we'll further guide you to payment processing and registration process. All right, guys. Thank you and all the best and happy weekend.
Thank you.
All right, guys. Thank you all. Bye.
Okay, thank you.